Right, so what we're going to do is the Vyatta Firewall lab. So you should find the lab sheet. Should explain how you need to do this. So what we're going to do is we're going to create a network with 3 main network interfaces, and then we use a Vyatta firewall in between to provide the routing between the networks and also to provide the firewalling. Okay, so if possible, you should try and complete it as a group, but if not, then you'll take control of the 2 virtual machines, and then you'll set up the whole of the lab yourself. Okay, so let's look at some basic theory around this. Okay, so here's what we've got to set up. The Vyatta Firewall is an open source firewall based on Linux, and fairly lightweight. It can run in the cloud and is inexpensive in terms of its cost and energy footprint and so on, and a very powerful firewall too. So what we'll do is we'll set up 3 networks. This is the public network here, this is the DMZ, and then this is the private network. So we have 3 different networks that we've got. This is 10.200.0.0, this is 10.0.2.0, this is 10.0.1.0, and we're using a /24 subnet mask. So the commands that we're going to use to be able to configure the IP addresses, that's the first thing that we typically do on our firewall, is to assign these onto the Ethernet interfaces. In this case we've sort 3 of these. We're going to set up the default gateway. Whenever a packet comes in and the router doesn't know how to get to that network, it sends it to the default gateway, which is over here. This allows us to be able to send things onto the internet. We'll have a Linux machine here and a Windows machine here. So the Linux machine is configured something like this, with a static IP address initially, and then the Windows machine will have an address which sits on this network. A key concept that we have is to be able to set up the default gateway. Default gateway for this machine is this port here, and then the default gateway for this machine is this port here. Okay, so whatever we set these up, then that is the default gateway for the host. And basically what happens if the packets aren't for the local network, it sends it to the default gateway, and hopefully the default gateway will be able to find a route for it. Okay, so what we're going to do is to set up the Viata Firewall, and the first thing we'll do is to set up the routing between the networks. So it knows what networks it connects to because we configure the IP address of each of the interfaces. And then what we'll do is we'll set up these zones. So these are zones, keep it simple: public, DMZ, and private. This is the least trusted, more trusted, most trusted. So what we normally find is that traffic is allowed to flow from a more trusted network to a lesser trusted. So the 2 firewall rules that we'll set up relate to firewall policies, will relate to the traffic that goes between the DMZ and the private zone, and the traffic that goes between the private and the DMZ. What we really want is to make sure that we can initiate connections from the private network into the DMZ. But when it comes to the DMZ to private, we don't want anyone to be able to initiate a connection in here and let that and create connections into the private. But what we do want is to be able to make sure that connections which are enabled from private to DMZ are then allowed to pass back. And we'll see how that works in a little minute. Okay, so what we're going to do is we're going to spin up our firewall, and so let's select 2 networks. So I'm just going to select 2 networks that hopefully haven't been used, and the 2 networks I'm going to go for are 40. So that's 24, and we'll go for 41. Okay, So our Linux host will sit at 10.0.40.7, same, and the Windows one will sit at 10.0.41.7. Okay, so that's the subnet mask. And for a firewall, so we want to make it, we sit on the networks. So our first network here is 10.200.0.0. Okay, so let's make that interface, we'll just call it Ethernet 0 just now. Let's make that the 254 address. Okay, for the next interface we have 10.0, this is our DMZ, 10.0.41.0/24, and let's make that Ethernet 1. And we will place that address at 254, put it at the top of the range there. And for the last one, we have 40, and it's Ethernet 2, and it's there. Okay, so that's going to be our pointer for setting up our networks. Okay, so make sure when you log into the vSphere that you actually view your VMs, and then you can actually see there's in production and there's SOC lab. What we're going to do is we're going to pick off a firewall, and let's power up this one here. We're going to power that on, and then let's go to our servers, no DHCP, and we'll pick up a Linux one, and we'll pick up a Windows one, and that's it really. Okay, so let's have a look. We'll have a look at our Vyatta Firewall, just booting up. We'll have a look at our Linux firewall, our Linux virtual machine, and we'll have a look at our, oh, got a little problem there with the disk on the Ubuntu one. Should be okay. Okay, so we're just booting up, so we'll just get logged in there. And there we go. And here we go over here. Okay, so I'm running this at home, and you can see it's running pretty well. And just log in there. Okay, so really we're going to now go ahead and set up our network. So we'll leave the firewall just now, so we'll configure the IP addresses for the hosts that we're going to connect. Okay, so our Linux machine over here, so let's go ahead and let's give it an IP address. Okay, so ifconfig. One thing we do is that we look at ifconfig. Always when we start up, look at ifconfig. So it's eth10. So sudo ifconfig eth10. Then we give it an address of our Linux machine is 40.7, and we define our net mask 255.255.255.0, and that's up. Okay, let's spell it right. Okay, much better. Okay, so the next thing we must do is we must set up the default gateway. So we can do that by adding a root. That's the default gateway, and it's 10.40.254. Doesn't exist yet, but it will soon, and that's fine. We often take the top address on the range as our gateway. So we have a look at our routing table. So our routing table should see that anything local gets sent to the Ethernet 10, and then everything else gets sent to the gateway 10.0.40.254. Okay, so I think that's us pretty much set up. We'll just quickly ping the port that we've created, just to make sure that everything's fine with it. Okay, so good. Gateway doesn't exist just yet, so we won't get anything for that. That's true. So now let's go over here and we'll do the same for our Windows machine. This time we're on the 41 network. Let's see if we can just drop down the resolution on the Windows machine so that we don't have to scroll too much. Okay, that's a bit better. Right. Okay, so I'll just go to our network. I'm going to give it a static IP address. There we go. And so then there. So it's 10.0.41. 41.7 and default gateway is there, so I think that's fine. Okay, don't worry about that. We're not using DNS just now. It just takes a minute to set. Okay, so that's us then. So let's just have a quick look, see if we can see that we're okay. Then we're just going to ping our own port. Everything's fine. Right, okay, so we're okay. So now what we'll do is we'll configure our Vyatta Firewall. Okay, just use the default login. So our configuration for the firewall is actually held in opt, Viata, etc. config, and then config.boot. So what we'll do is that we'll just reset the config and just go for default boot, and then we'll copy that into where the config for the firewall goes, just so that we know that it's all reset. Config, and then it's config.boot. Okay, then we'll just reboot it, just in case. Okay, so it's just going to boot, and then what we'll do is we'll go ahead and we'll set up the IP addresses for it. Set up the default gateway, then we'll commit to it, and then that will be it. Okay, so there we go. Boots up nice and quickly. So there's two main modes. There's the edit mode, the configuration mode, and there's the main command mode. So what we'll do is we'll just get logged in. Okay, Viata. So anytime you can show the configuration, just press tab and it'll do an autocomplete. So we've got 3 Ethernet ports, Ethernet 0, 1 and 2. They only have MAC addresses, nothing else. And we can show our interfaces just to check they have no IP addresses. So everything's good, and what we'll do is we'll just go ahead and we'll configure it. Okay, so at any time you can press question mark just to see where you are, but we're going to configure the interfaces, and it's Ethernet. ETH0 is the one that's connected to the public network, so I'll give that an address such as this. Okay, we just missed off the address there. Okay, so the easy way to do it is just to recall the command with the up and down arrow, and it just is quicker rather than having to retype it again. So our network that we've got is on the 40 network. So we'll take the 41 network as our DMZ. Then the last network is our private network, and that's Ethernet 2. Okay, so nearly there. So then what we do is we set the system gateway as to the place that we send all the data packets if we can't find the route for them. That's the main gateway into the network. So we should find that when we now go and ping, it hasn't actually done anything. So we can ping there, and let's see if we can ping the gateway here, 254, and we get nothing. Okay, so what you've got to do is you've got to commit. So only when you commit does it actually do the changes. So now, hopefully, fingers crossed, there we go, our gateway exists. We're very lucky, then we can get across into the Linux machine, and there we go. So we now have routing between the two machines, and hopefully when we go to our Linux one, we can ping ourselves. We can ping the gateway, and we should be able to ping the other Windows node. That's great. Okay, so we haven't applied a firewall yet, which means that there is no firewalling. All the routes are enabled. Everything is actually fine. Right, so we'll just fire up Wireshark just so that we can actually see those pings coming through. And so Wireshark, and then we'll put it into the background. I'm just going to start up. Look how quickly that is, just fantastic. Okay, so you may find there's a little pesky message around the back. Just make sure that you click on that. Okay, so we'll just go ahead and we'll ping again. This time we'll ping the other network. Okay, so the what we want to see is the request and the reply for that. Okay, so let's have a look at that one. Okay, so what we should find, so this is the request that goes out. Okay, so there's the request. If we have a look in here, we should see there's an opcode of type 8. So it's opcode ICMP 8 is a ping request, and then the ping reply that comes back, in this case it's a successful reply, we should find is actually the Linux one isn't so easy to control. Hit itself around the back. Okay, so there's the reply. Okay, so next reply is an ICMP code 0. Okay, so that's it's important that you remember some of these codes. Okay, so we can actually have a look to see what our configuration looks like. Okay, so what we do is we've committed, and we can exit, and we can show our configuration here. There we go. There's our addresses on our interfaces. And we can show our interfaces here. Okay, so there's the basic setup for it. So what we're going to do now is we're going to delete one of the interfaces, and we'll see how that affects our firewall or our routing between the two networks. So we'll just disconnect them. So the quickest way is probably just to recall your commands here. So I'll get rid of this interface IP address here. So we'll just delete. If we now go back, what we should find is that we can't actually, we can, because the reason we can is that we haven't committed it. So just make sure you always commit to the changes, and it doesn't work anymore. Okay. So we'll just go back and we'll actually put it back in as before. Okay, so it shows you the importance of having a gateway. Set up that again, and everything should be fine. Go back here and we'll do our ping, and everything is all back to normal after I commit there. Okay, so you've seen the minute I did the commit, then it was fine. So what we'll have to do is, your ARP cache is very important. So the ARP cache either has static addresses or dynamic addresses. So it learns the gateway normally through dynamic addressing. So we can see here the MAC address of the gateway is the only machine that it's actually known on its own network, 262F. If we actually have a look at our configuration, hopefully we should see that that's the MAC address that we've got. Okay, so there it is there, Ethernet 2, 262F. It's done an ARP to be able to discover that one. And then if we go over to our Windows machine, if we can just find it. Yep. Okay, let's look at our ARP cache. -8, and this is 4584. There we go. So you can see there we can change the MAC address of the firewall if we want, because it's a virtualized firewall. So it can be set whatever we want. Now what we'll do is that we'll actually now go ahead and we'll use a browser to be able to connect onto the other network. So this is as in the DMZ. So that's 40.7 takes it to there. Okay, so that's we're able to get good connectivity. The other way we can do it is that we can use Telnet to be able to, if the browser doesn't quite work, then we can use Telnet. So we want to get into .7 and then we do it on the port 80 port. Okay, that's it. So our connection is there, get index.html, it comes back and that page is not found. Okay, so you can go ahead and do it from the other side. There could be some problems with the firewall on the Windows machine, not quite working right or set up. So we'll just give a quick test, but don't worry too much if it's not actually giving you it, but it is. So that works perfectly. So again, we can go and we can do the same with telnet to 10.0.41.7 port 80. Perfect. Okay, so we wouldn't get the connection there if it didn't do that. Okay, so that's fine. So we can get connectivity to the web server. So as before, we can go back and then we can disable again. So let's do that. Let's go into configuration first, and let's delete our interface and commit. Let's go over here, and it depends if it's in the cache, the browser cache or not for the address. You just got to make sure it gets refreshed correctly. Okay, so it's in the browser cache and it's just not updating. So the way that we test that it's not working is we'll go back here, and there you go. So now we're not getting connectivity. Okay, so let's go back and set it up again, just to show that we can get access to the services. Okay, so we should be fine now. Now what we're going to do is we're going to Nmap, and Nmap will allow us to have a look to see what the services are on the other host. And again, so we'll just run Wireshark. Just to see what it's giving. And so we're going to Nmap the Windows machine, which is on 41.7. Just do a quick Nmap. Whew, that was quick. That was so quick. So if you go to the Windows machine, we'll just run Wireshark. And just to prove that it is actually Nmapping it. Okay, so we're going to capture, select an interface. And we'll take it from there. Go. Okay, so let's do it again. And we'll see the damage it does on the other side. Okay, there we go. Look, here is all the sins and the ARPs and so on. Okay, so there's a lot of ARP activity for the REST and other nodes on the network, so just ignore them. And we'll just stop that. Okay, so here is an Nmap. So Nmap sends in a SYN on a port, and if it gets a SYNAC back, it knows the port is open. So there's this SYN there. There's the SYNAC coming back. If it's not open, then it'll send back a reset ACK, and we should see lots of reset ACKs because there's lots of ports that aren't actually open. So there's an example of one there. Okay, so there's the SYN going in, and the server responds back with the reset ACK. Okay, so it's able to determine these ports. So you should be able to go on to the Windows machine, and again we should be able to Nmap 10.0.40.7. There isn't as many services running on the Linux machine. I think we have the web server and telnet and so on. FTP, telnet, HTTP, LDAP and VNC. Okay, so that's the main services that we've got running on there. Right, so the next part of this lab, what we're actually going to do is set up a DHCP server actually in the firewall, and that will give an IP address to the machines on the different networks. So to do that, we'll actually set up the service. Okay, so set up service, you can have a look at the services. We can have DNS, HTTPS, SMTP, SSH, Telnet and so on. But initially we'll just set up our DHCP server. Okay, and then we want shared network name, and we'll call it ETH1, just give it a name. So anytime you can type in the question mark, and that should tell you what it's looking for. It's just looking for some text. And then the next thing it's asked for is a subnet, and so our network is here, 2024, and then the starting address, we can define a starting address. So let's go for .8 as a starting address, and then for stop, this is the end stop for the addresses to be given from the pool, so we'll just stop at 100. Okay, so the next thing we need to do is to set up the default router, so that's the default gateway really. So Viata actually knows automatically which network that is going to be allocated to, because it knows what the IP addresses of its port is. So let's set up our default subnet again, 10.40.0/24, default router 10.40.254. Okay, so remember, commit. Okay, so you can look at your configuration if you want. So first thing that we'll do here is to release our IP address. I just have to take super user access. So we've released it, and now what we'll do is we'll get it back. We'll get one from hopefully the server. Brilliant. So that's really good. So we started the pull off at 10.0.40.8, and that's what we've been given. It's also set up our mask here, and hopefully it's set up the default route to go via 10.0.40.254, all done from the DHCP server. So let's go ahead and we'll ping our Windows node. So everything is fine. So we're now using DHCP, so you can see that that works very well. Okay, so have a look at the Wireshark trace and you should be able to see what ports it uses. In fact, it's such an important protocol that will actually go and run Wireshark again. And we'll have a look to see what it actually gives us. Okay, remember that little thing there? Okay, so we're going to go again and we're going to do our release. Then we're going to do our grant. Okay, so that's it there. So let's find our Wireshark trace. I'm going to bring that back and then we'll just stop. Okay, so here's the DHCP release there. Okay, so it uses a source port 68 and destination port of 67, and then what it does is it sends out a request, a boot request to the gateway, and then so that's released it. It's because we had already bound it to the DHCP server, so that's releasing it from the current one that we had before. Now what it does is a silly thing. It broadcasts to the whole network. Okay, every node on the network sees it, and it's asking for a boot request, 68 and 67 this time. And then what we get back is an offer. Okay, so it's been offered an address here from one of our servers here. So it's been offered from the default gateway. Okay, so it goes and requests it. Okay, so the request it's given is 10.0.40.8, and if it takes the address, then there'll be an ACK. Okay, so it's now being granted its IP address. Okay, so you can see that this is a protocol that could be easily tampered with, and it should be watched with great care. Okay, so if we like, normally we would set up our SSH, but we'll just do it with Telnet just now. So we'll set up a Telnet service, and then we'll commit to that one. And then what we can do is we can Telnet into our gateway 40.254. There we are. Okay. That's us in there. Okay, so that's really identified how we can set up some services on it. Okay, so now we get to an important point. So we can see up to now we've been able to move between the different networks, and obviously that's not really what we want. We want to be able to firewall between our different networks. Okay, so let's see if we can find our diagram again and to look at our zones. Okay, so the Vyatta Firewall works on zones. So what we have is a number of zones that we set up to keep it nice and simple. Okay, private, and we have DMZ, and we have public. Okay, this is least trusted, more trusted, most trusted. So we'll set up our zones and we apply them to our interfaces. And then what we'll do is we'll look at the firewall rules, and then we'll apply it between the traffic that goes between one zone and another. Obviously we would set up other traffic flows between here and here, between here and here, and so on, but just to keep it simple, we'll just set up the two routes. Obviously the traffic that goes this way would probably be barred completely. We don't want any incoming connections into this private network. They've got to be established from the private to the public network before they can come back in. Same again, we don't really want the whole anything from the public network to go right into the DMZ, so we typically just allow a bunch of holes in the firewall. So for this, we'll make sure that we can allow certain connections to be initiated from the private to the DMZ, and then the only connections that are allowed are the connections that are already established from this connection to go back from the DMZ to the private. Okay, so let's go ahead and let's configure our firewall for this and see where we get to. Okay, right, so we're in configuration mode, so we don't want to do that, that's for sure. Okay, so there's our zone policy, our zone, and we're naming it private. Okay, so that's a private network, and we'll just give a little description and we'll call it inside. We're going to set our zone policy, zone, and then this will be our public network. We'll give a description of outside. We like to keep things nice and simple. And again, our zone policy, we'll put our zone in and we'll make this the DMZ. And there, and then that's the place that we put all our forward-facing servers and so on. Okay, now what we'll do is we'll apply the zones onto the interfaces that we have. So the public goes on to interface E0. So now we set the policy for the private. Onto interface. It doesn't matter which one you put it on because we've put the same network on both, but we'll put that one on Ethernet 1. And then we'll apply the zone policy. Just let us check what we've applied there. Okay, so I think we applied the so that E1 should be the DMZ, as I remember. Okay, so the private goes on to Ethernet 2. I think that's what we set that one up as. And the DMZ goes on the Ethernet 1 adapter. Okay, so we've now applied, so just let us commit that. And we'll just go ahead and check what our config is. Okay, so Ethernet 1 is our DMZ.41. And for our zone policy, we've applied it onto Ethernet 1. Okay, so I think we're fine. We're fine there. Okay, so now what we'll do is we'll see if we can actually get access to any of our services again. So we'll bring up our Linux machine. Probably easier to do it that way. Quickest way is just to really run Nmap again, just to see if we're getting anything coming through. Okay, so absolutely nothing. Okay, telnet 10.0.41.7 on port 80, nothing. Okay, so what's really happened is we've now applied the firewall and it's blocking everything. So out the box, a firewall will generally block everything. So now what we'll do is that we'll now set up our firewall policies to be able to allow access or not. Okay, so we'll go back into our configuration mode, set the firewall name, and I'm going to call it DMZ2 private, and give it a description of DMZ to private, just as documentation there. Okay, so the next one is that so this is from the DMZ. So what we want to do is we want to make sure that it doesn't allow any connections through, only ones that have been established before. So we'll accept that. That means accept with this rule, and then we'll actually define that only established connections, and these are related. Okay, so that's our first rule set up. That's looking good. So we'll apply that a little bit later, but then what we're going to do is set up the rules for our private network. Okay, so firewall name private to DMZ. So this is going to be different. This one is from a private network to a DMZ, which we're going to punch through some ports. Okay, so just recall it there. And rule number 1 is the action is to accept. The default is reject, so we need to accept it. And again, we'll accept connections that are established. Okay, once it's been established, then we'll just allow them through, and the firewall will remember them. Anything related to the connection, such as when we use passive FTP, anything related, we're going to enable that too. That's a good one. And now what we'll do is we'll put in another row here. Rule 10, action, we're going to accept destinations. So what we'll do is we'll open up port 80 and port 443. Sorry, I need to put the port in. 80 and 443. And obviously the protocol is TCP, not UDP. Here's the ports, here's the protocols, lots of them, so just go for TCP. Okay, so what we've done there is that we've allowed established connections to happen, but we've also allowed port 80 and port 443 to be allowed. So we should be able to Okay, so we've set up the we've applied the firewall rules onto the zones. Okay, so we'll just commit that. Okay, so now what we should be able to do is that we should be able to access the web server on the DMZ, and that's good, so that's fine. So the firewall's working there, but what we shouldn't be able to do is to go to our Windows machine, which is in the DMZ, and let's see. So just log in. So fingers crossed. There we go. Okay, firewall is working perfectly now. Okay, so you should find that telnet doesn't work because we didn't allow that. Okay, so what we can do is we can go back to the firewall. Okay, so telnet doesn't work, so we'll just go back to here, and then we'll just go to our rule that we created earlier for that. We'll just delete it. Then we'll reapply it, port 23 this time, and set, commit. Over here. So let's go again, and isn't that brilliant? so that's allowed us to be able to view that. So what we'll do then is we'll actually have a look to see if we can actually run Nmap now. So if we run Nmap 410.41.7, it should only show us the 3 ports that we've opened up, or actually 2. So you can see here where before we got lots of ports, we're only punching through on these 3 ports. If we then go over here and we run the Nmap again, we'll get absolutely nothing because our firewall has blocked all our ports. Okay, so there you go. And that shows that that's doing that. Okay, so now what we'll do is we'll run hping against there. Okay, we'll do it on port 80 and we'll send in a SYN flood. Should see that gets through. Okay, so we could run Wireshark to actually have a look at what it's actually giving us. Okay. Okay, so a particular problem that we have is when we have a denial of service from one network to another. So in this case, we might have a denial of service from this node into the DMZ. So we're going to set up some protection for that. Okay, so we're going to set up another rule, and this time we're going to add it on to the private to DMZ, rule number 5. And the action is to drop. Okay, that's different from before. This is dropping something. And name private. And the protocol is TCP. And what we'll do is we'll set up a rate limit on the following ports. We'll make it 21, 23, 25, 80 and 443. And so next what we'll do is we'll set up recent. So that's the number of connections that from a single address. So we'll say 5. So if there are 5 connections within certain time, 10 seconds. So 5 connections in 10 seconds, then don't allow any more. Okay, so this should hopefully stop denial of service. So we'll bring up our hping again. So we're going to ping. Oh, so there we go. 40.7. We're going to port 80 and we're sending in a SYN flood. Okay, so there it goes. Okay, so oh, it's the wrong IP address. Sorry. We want to go 10.40. So let's just see if we can ping 10.0.41. So let's get it right. 41.7 is our node in our DMZ. So there we go. 1, 2, 3, 4, 5. Stop. Okay, so it's stopped because it's continued to send them, so it's reached the rate that we can actually go at. Okay, so that shows how you can actually do that. So the same can happen for our FTP. So for our FTP, we could set a rate limit of 2 over 10 seconds. If we try to log in twice, then that will limit us. Okay, so a great little feature inside our firewall. So the last thing that we're going to do is that often ping and ICMP are really barred from the network. It's not really something that we might want someone to do between our networks. So let's actually, so it's already banned from our DMZ into the private network, so let's bar it from our private to DMZ, and we'll just add it on to this rule. So the action is to drop. Create a new rule number. So we want to drop, and we want to drop protocol of ICMP. Okay, so let's have a look. So now what we should have done was that we should have now barred ping from here, ping to 41.7. And there we go. Okay, it's just not pinging at all. Let's actually erase it just to show that it actually works. Oops, delete. Let's delete it. Delete. And let's delete the other one. By that one. Doesn't really matter too much for that one. Recommit. just make sure that we can now ping. Okay, so we can ping, so you can see our problem is that we need to allow it because we've only allowed on port 80 and 443. So let's go ahead and we'll actually permit it. Okay, so it would have been easier probably just to set up this actually. Okay, I'm going to accept that. Isn't that fantastic? Okay, so now we've opened up the firewall to be able to allow ICMP coming in. If we wanted, we could just go back to this one. Let's do it live just to show that it works. So what we'll do is we'll go back and we'll get rid of that. We'll delete that one. Drop. And you should see on the ping there, once we do this, stops. Okay, so that's shown us really how we can protect our networks.